Good morning, everyone. Let's start the class today. So, let's go back and revisit what we had done in the class yesterday. So, I started the introduction to design chapter and we covered some concepts like we talked about the importance of design, right? And we looked at what are the high level and the low level design and what are the activities associated with it. I also told you that in design, what we do is in this phase, we basically, transform an SRS into some design documents, which are nothing but a set of diagrams, right? And the activities which are involved in, doing this transformation are all related to the design activities, right? I also introduced you and discussed the characteristics of a good software design. We also talked about how a design can be modular and can be layered, and we saw an example of how you can have a design which is good, right? So the right hand side design is good and the left hand side design is not good because it has poor modularity and there is no hierarchical structure here, or there are no layers. In the design that is on the right hand side, we saw that everything is organized into a layered form. There is a hierarchy, right? And everything is very nicely done. So this looks like more modular than the one on the left. We also discussed the concepts of fan in and fan out. I told you how you can identify a library module, right? So if you have a module which has got many fan ins but no fan outs, then that module basically has shared functionality, which is good because you are trying to reuse the code, right? So that's what we had done yesterday. Now today I'm going to introduce you to two concepts in design, and they are called as cohesion and coupling. Okay, now why do we need cohesion and coupling, and what exactly is cohesion and coupling? Now if you have kind of all of us have done, right, physics, we've studied physics, and you may have come across this word cohesion there, right? I mean, I don't know whether you remember that or not, but in case you do, we had kind of learned that cohesion is basically when you have one water drop and another water drop, right? Suppose you have one drop of water and another drop of water. If you bring them close, right, what happens is they will, as soon as they come close, they will stick together and they will join into one single, one large drop of water. So one drop of water, another drop of water, when you bring them close and when they touch each other, immediately they kind of attract towards each other and they join together to form another big drop of water. Now, between these two drops of water, there is some kind of attraction. Okay, there is some kind of attraction. Now, this attraction was called as cohesion in physics. Okay, so cohesion is basically a form of attraction between two similar kind of molecules. Now that's physics, okay, but the same concept is also there in software engineering. So to understand what is cohesion, cohesion means the attraction between two similar kind of molecules like water, right? But now we have also seen that there is something called as, right, adhesion, okay, in physics, but we will not look at adhesion. But let's try and understand cohesion first. So cohesion is a kind of force of attraction, or it's a force, or it's some kind of force which keeps the similar kind of molecules together. Okay, just remember that because we will try and correlate the same concept into software engineering. Now what is coupling? Now coupling is also a kind of force. Okay, coupling is also a kind of force. So when you have two similar objects and there is a force of attraction between them, we call them cohesion. But if we have two dissimilar objects and if there is some kind of a force of attraction between them, then we call them as coupling. So cohesion is between similar type of objects, similar type of molecules, similar type of things. Coupling, again, it's basically the relationship, or basically it's kind of the force of attraction, but here it's two different molecules, two different objects. Like for example, when we see a boy and a girl together, we call them as a couple, right? Why we call them as a couple? Because boy and girls are different. So there is some, because they are together, then they are couple, right? But they are different. Boy and a girl are two different kind of objects, different molecules, you can say. Right, so same concept we can try and understand in software engineering. Now, before we move on with what is cohesion and what is coupling in software engineering, let me tell you that in software engineering, these two concepts are used to see how good our design is, right? Now, there is no direct measure, there is no way by which we can directly measure the modularity of a design, right? We can't. There is no number. We can't measure it using some, kind of a tool or something and tell that, okay, fine, the design is 9 out of 10 or 8 out of 10. That's the, kind of what is the modularity of the design. It's not easy to kind of, find out whether the modularity is high or low, right? We can only quantitatively characterize the modularity of a design. Okay, quantitatively means what? Right? We cannot actually give it a specific value, right? We can only kind of look at the modularity in terms of cohesion and coupling in the design, and we can say that, look, this design has got a high cohesion or a low coupling. So you cannot have a value, you cannot associate a value like 9 or 10 with a design. Like we can't say like 9 out of 10, but yes, we can give it some kind of kind of a term like good and bad, high and low. So we can define the modularity of a design based on cohesion and coupling. And also in this, we can say that yes, the design has high cohesion or a low coupling, or a low coupling and a high cohesion, or vice versa. So depending on low cohesion, high cohesion, low coupling, high coupling, we can identify whether our design is highly modular or not. Okay, now those designs which are good and which are supposed to be highly modular designs have high cohesion. Just remember that, because then we will discuss what exactly they are. They will have high cohesion. Okay, a good highly modular design will have high cohesion, and it should have low coupling. Okay, so our target would be, when we are doing a design, when we are trying to make a design, when we are trying to get all the modules together, our focus should be on achieving a high cohesion. That means similar kind of molecules, right? Attraction between similar kind of molecules should be high, and the attraction between two different kinds of molecules should be low. All right, so with this we can go ahead and see exactly what this cohesion and coupling in software engineering means. Okay, so let's try and go back to the previous class where we had structured our SRS. So if you remember, we had structured our SRS and we had drawn some diagrams. Let's see. Right. So yeah, same one, but I think there's a better one. If you look at this diagram here, what we had done here was we had organized our requirements into 4 different modules: M1, M2, M3, and M4, right? And how we had done it? Because we had seen that there were a group of requirements which were common, which had relations with each other. That means all the requirements, all the requirements which were related to each other and served a common purpose were grouped as one module, right? So M1, M2, M3, and M4 were 4 different modules that we had discussed. Okay, now I'm going to introduce the concept of cohesion and coupling with respect to these 4 different modules, M1 and M2. So let's see how that works. Let's say I have 4 different modules. So here is M1 and here is M2. This one is M3, and let's say we have M4. Okay, so M1, M2, M3, and M4 are my modules, right? The reason they are my modules, because the requirements of each of these modules are different. That means M1 module, the requirement that the kind of functionality that M1 is going to fulfill or implement, right, is going to be completely different from M2, and that's the reason why we have separated it out into different modules. Now inside M1 I have many small requirements, right? So inside M1 I have small requirements, right? Why I have grouped all these requirements together? The reason is because they are common, they have some kind of relationship between them, and that's the reason they are all grouped together, right? So every module will have smaller requirements, and all of this we have seen how we can structure it in an SRS. Okay, now let's look at cohesion and coupling. Now if I look at the requirements, right, if I look at the requirements inside a particular module like M1, if you look at the requirement inside M1, these requirements will be related to each other and they will be similar to each other. That means they will be related to each other, right? Similarly, the requirements, all the sub-requirements inside M2 will be similar to each other. That means they will be related. I told you that these will be related to each other, right? Now imagine, we have done the grouping wrong. We have done the grouping wrong, and one of the requirements from M2 has come into M1. Because we have made something, when we were doing the grouping, we kind of made a mistake. And, one of the requirements from M2, we kind of grouped it in M1. And one of the requirements from M1, we wrongly grouped it into M2. Now what's going to happen here? Let's try and discuss. So we have all my requirements here, right? So M1 has got everything correct except one requirement which should have been there in M2. Now there is a problem here. What is the problem? The problem is all the requirements inside M1 are strongly related except one, right? So this requirement will have infinity or will have some kind of connection with M2. Similarly, one of this requirement which is there, which I have written or colored it in red, this will have a connection with M1 because the grouping is different. That means M1, one requirement will try and connect with another requirement, requirements of M2 because the group is different. And similarly, one of the requirements of M1 which I have wrongly put into M2, that requirement will try and connect to its original group, that is M1. Now let's look at cohesion. Now what is cohesion is, if I have all the proper requirements inside M1, all these small requirements, and they are related to each other, that means the bonding between them will be very strong. That means when I look at a module, and inside the module, when I look at all my requirements, the attraction or the relationship between all the requirements inside my module can be called as cohesion. Because they are all similar in nature. That means they are all a part of one module. They have something in common. They are related to each other. That means the force of attraction or the relationship between two different requirements, two or more requirements inside a given module, that is called as cohesion. Okay, because they are all similar in nature. What is coupling? Coupling is the relationship or the force of attraction between two different modules, because each modules are different from each other. So if you look at M4 and M3 or M1, M2, M2, M4, M2, M3, these are all different molecules. These are all different modules. They are all different from each other. The functionality that each one of them are going to fulfill or that we are going to implement are going to be different. So the attraction or the relationship between modules is called as coupling. And the attraction or relationship between requirements inside a given module is called as cohesion, because they are similar in nature. All the requirements inside a module, the force of attraction between them is called as cohesion. Now, if you look at these two groups, you will notice that there will be a very strong bonding between all the requirements inside M1, right? That means they will be very strongly bonded to each other. That means the force of cohesion between all the similar kind of molecules will be very high, because right? They are all, in the same group, they have something in common, they are all related to each other, right? So good high cohesion is good for your modular design, right? Low coupling is good for your modular design. Why low coupling is good for your modular design? Because two different modules should be independent of each other. That means they should not have a very strong connection. If you have a strong connection between two different modules, that means those modules are not modular. That means one module is dependent on the other module. Right? That means if there is a dependency, even when I'm implementing it, there will be that dependency in terms of implementation. One person has to wait for the other module to complete, then only he can do the coding, or in case he has to complete one part of the module, he has to be dependent on the other person who is completing another module. So in order to, kind of implement modularity, we need to minimize the coupling between two different modules. Minimizing the coupling becomes, what happens is a particular module becomes functionally independent of each other. Okay, now look at this example which I have actually, I drew some time back. Now look at this blue here, right? Sorry, I just need to use another color here. Okay, so if you look at this requirement here, this requirement basically is supposed to be from module M2, right? But it has wrongly come into M1. Similarly, one requirement here, this is supposed to be in module M1, and this has wrongly come into M2. Now, because of this problem, what has happened is there is some kind of dependency between these two modules. Okay, there is some kind of dependency between these two modules. Why there is a dependency between these two modules? That means one of the requirement from one module has gone to another one, and another requirement from another module has come to this one. So both the modules are related to each other. That means there is some kind of bonding starts happening because of, improper design, improper requirement analysis, right? So what happens is, because of one requirement here, the bonding of this requirement with all the other requirements are going to be weak, because this is not a part of this group actually. So there will be a strong, bonding amongst all the different, requirements except for this one, because this one does not actually belong to this group. That means overall, the cohesion of this module will weaken because of this one requirement. Similarly, the overall cohesion, that means the bonding between all the different requirements inside this module, will weaken because of this requirement. Why? Because this requirement is not a part of this. So he or this requirement will not be able to connect with all the other requirements. This requirement will try to connect to M1 because this belongs to this group. So what happens in this case? The overall cohesion of these modules will decrease because of one wrong requirement which has been placed here, right? And alternately, what's going to happen is, the bonding between these two modules will increase because of this wrong placement of one requirement. That means the coupling is going to increase because this requirement will try to connect to this module, this requirement will try to connect to this module, whereas the cohesion will reduce. Now, if I take this requirement from here and kind of place it here, and take this requirement from here and place it here, then what's going to happen is, I am going to have a scenario where each requirement in this group is now correct. That means there is no problem with my design and my requirements are all correct. Now, when this happens, all the bonding amongst all the different requirements inside one module, both the modules will become stronger. That means my cohesion is going to increase now. And also the relationship between these two modules, which had actually come into existence because of wrong placement of the requirements, now this requirement, this coupling, that is nothing but coupling, the coupling will become low, right? The coupling will become low. Why? Because there is no dependency of one module into the another module. Okay, so this is the concept of cohesion and coupling. And cohesion is what? So let me just kind of summarize it for you. So cohesion is a measure of the functional strength of a module. That means what is the functional strength of this module is defined by all the requirements which are put inside. if I have done the design properly, if I have put all the requirements, which are common, are related to each other, that means my module will be functionally strong. And cohesion is the measure of how, strong a module is functionally. Okay, a cohesive module, that means cohesive modules, all the functionalities inside that modules work together to perform a single task or function. That means all of these requirements will work together in sync to perform the function of this particular M1, right? If we don't, if we don't kind of place the requirements properly, then together they will not be functionally strong. Okay, what is coupling? Coupling is the measure of the degree of the interdependence or interaction between the two modules. How the two modules are dependent on each other, right? It's a measure of the degree of the interdependence or interaction between two modules. How closely they are dependent on each other or not. So having low coupling is good for your design because I don't want any dependency between two modules. The modules should be functionally independent. Okay, so a module which has high cohesion, let's go back to our previous page. So a module which has high cohesion and low coupling is said to be functionally independent of other modules. Okay, that means a functionally independent module has minimal interaction with all the other modules. Okay, so what are the advantages of this functional independence? All of us like to have independence, right? So what is the advantages of functional independence in a design? Okay, functional independence in the design means that the design is first of all very modular. Each of those modules are not dependent on other, they are independent of each other, right? And some of the advantages of functional independence are that first, you can better understand, that particular design. There'll be the understandability of the design will be good. It will be easy to understand what's happening because the functionals, all the functions, all the modules are very nicely separated. Second thing, the complexity of the design is reduced. That means the design is much more simple because there are not too many dependencies, right? So the complexity of the design is low. Second thing is different modules can be easily understood in isolation, which means I can take one module and understand it. I don't need to look at the entire picture in one go. I can just keep looking at one module and I can understand it because that module will not be dependent on other modules. That means modules are independent. Second thing is the functional independence basically reduces the error propagation, right? Because the degree of interaction between modules are low. That means if there is, so for example, here is one module and there is another module and there is no dependency of one module to another. That means if an error is found in this module, right, it will not affect this module. But if there is a very strong bonding between, if there is a very strong bonding between different modules, then if the error is there in one of the modules, if there is a bug here in all the modules, this will affect all the other modules as well. So functional independence, right, reduces even error propagation. So if the error happens here, we know that the error will be contained in that module itself. It will not propagate to another module because there is no dependency of this module on another module, right? So error will be confined to this module and we can easily, locate it and we can easily fix it. If we fix this, then, we can fix it only in one module. Otherwise, we have to go and look at all the other modules and then make changes there. And the last one is if you have functional independence amongst the module, that means if the modules are independent, then you can reuse the modules. Okay, the modules can be reused. All right. So basically, this is what cohesion and coupling is, right? But we have a way of classifying cohesiveness. That means now since we know what exactly is cohesion and coupling, Now we need to understand the different types of cohesion. Okay, now there are different types of cohesion, and each of these types will tell us whether the cohesion or whether the coupling or whether the cohesion is strong or weak, right? We can say that if we have now, what exactly is classification? First of all, let me ask, what is classification? Right. Now, when we talk about classification, classification is a subjective idea. Okay, when we classify something, it can be into good, bad, high, low. These are the kind of terms that we use. Although classification is most of the time subjective, it can give us an idea about cohesiveness of a module. So if we can classify the different types of cohesiveness, we can find out about what is the cohesiveness of a module. For example, by identifying, by examining the type of cohesion exhibited by a module, we can roughly tell whether it displays high cohesion or low cohesion. Okay, so there are different types of cohesion, and each of these types of cohesion, have some degree. That means they have some degree of cohesion. So degree of cohesion means, suppose you have a particular type of cohesion, that is basically an indication of high cohesiveness. If you have a particular kind of cohesion, that is a degree of low cohesiveness. Okay, so let me just write down all the different types of cohesion that can exist in a module. So first of all is functional. Okay, first I'm just going to write everything down. So functional cohesion is a type of cohesion. I will take an example of each one of this and I'll tell you what exactly functional cohesion means. The second one is sequential. Okay, sequential cohesion. The third one is communicational. And this is very important. This particular concept of degree of cohesion and the types of cohesion are very important concepts. So you must understand them and you must also learn them well. And the fourth type is procedural. The fifth one is temporal. One more is logical. And the last one is coincidental. Okay, now these are the different types of cohesion that can happen in your design, that can be present inside your module, right? And the degree of cohesion, it goes along this way. That means, let me just write it down. So this is basically the degree of cohesion, which runs from coincidental to functional. That means if you have functional cohesion in your module, your cohesion is, the cohesiveness of that module is the highest. If you have coincidental cohesion in your module, that means your cohesion is very weak. That means if your requirements are coincidental, right, that means in that particular module the cohesion is very weak, or it has a very low cohesiveness, which is not good for a design. So when we are trying to kind of structure the modules, when we are trying to group the requirements into modules, into high level requirements, we should ensure that we attain this functional cohesion. That means most of the requirements should be functionally cohesive. Okay, if you have functional cohesion in your module, then the degree of cohesion is very high. All right, now obviously we can look at each one of these, right, one by one, but I think we can take that up in the next class. In today's class, just try and understand this concept of cohesion and coupling, because each one of these once again we will go through it very slowly, because this is important to understand, right? So what is the degree of cohesion? Now before we actually move on and end this class today, let me talk to you about coupling also, because there are different types of coupling. Now since we have degree of cohesion here, we have classes of coupling. Okay, so these are the different types of cohesion. So let me write, let me just change the color. And okay, so the different types of cohesion are listed above. Okay, these are the different types of cohesion, and the degree of cohesion also is mentioned, which tells you that which type of cohesion can make your module, or can have bring about a high cohesion in the module, right? So the functional cohesion is what we need to achieve. Sequential communication, so basically these if you talk about functional cohesion or sequential cohesion, communication cohesion, these will actually bring about, this will make your module stronger in terms of cohesion. But if you have these, then they will make your module weaker in terms of cohesion. That means your cohesion will become low. Okay, now these are cohesion. We can have coupling also. So there are different types of coupling, and these type of coupling will define whether your module has got, what is, again, we also have a degree of coupling, and your degree of coupling also kind of tells you whether the, what you call, two modules are independent or not. That means what kind of coupling can cause a low degree, that means can cause a low coupling. So I'll just write down the 5 different types of coupling that can exist between two different modules. First one is data, second one is stamp, the third one is control, the fourth one is common, and the fifth one is content. Okay, now which is good, which is bad? The degree in this case is opposite. That means we should try and achieve data coupling amongst the different modules. That means this is the degree of coupling. That means if we have data coupling amongst the modules, that means the degree of coupling is low, which is good, right? We need to achieve low coupling and we need to achieve high cohesion. So if we get data coupling, that's the best. Stamp, better than data, a little bad than data, but still it's not bad. But if you have content coupling and common coupling, then it is bad for your design. Similarly, functional, the best. Sequential, good. Communicational, okay, we can work it out. But once you start into temporal, logical, and coincidental, that means these are bad for your design. So the objective should be to have low coupling and high cohesion. That we must try to use only data and stamp, and here we must try to achieve functional, sequential, and communicational cohesion. So when you look at a design, right, we can identify what kind of requirements you have put inside, what kind of requirements you have grouped, right? So if you have grouped your requirements in such a way that they exhibit functional cohesion or sequential cohesion or communicational cohesion, that means it's good for your design. That means the cohesion of your module is going to be high, which is good. But on the other hand, if your requirements are, have data coupling and stamp coupling, it's good for your design because the modularity is there, because the dependency between different modules are low. That means the degree of coupling is low. But if you use common and content coupling, right, which means that the two different modules are very strongly related to each other, that means the degree of coupling is high, which is not good for our design. So for a good design, we need to have high cohesion, low coupling. And it's like, it's like inversely related. It's inversely related. For example, if you achieve functional cohesion, automatically your coupling will become low. If your coupling is high, that means the degree of coupling is high, that means your cohesion will become low. So if you try to increase one, the other one will decrease. So in case of, if you're using content and common coupling, most of your requirements, are, you have a content and what you call common coupling in your design, then automatically, right, you will not have these in your what you call module. Your module will exhibit mostly these three. That means this will achieve the common and content coupling, will cause your coupling to become high, degree of coupling will increase, right? So this will have a high coupling, and automatically your cohesion will become low here. So it's inversely proportional to each other. High cohesion will get you low coupling, high coupling will get low cohesion. Okay, so we can stop here for today's class, and from tomorrow we will try and understand each one of them. We'll try and look at each one of them with an example and see how these different types of cohesion and coupling is actually achieved. Okay, so we can stop here, and if you have any doubts, please get back to me, and you can always write to me or send me a WhatsApp or whatever it is message, and we can clear it out. So we'll meet again in the next class. Please go through it very carefully because this is an important concept that we need to understand. So we'll see you again tomorrow. Bye.